Hello, good afternoon. My name is Artur Rocha, and I'm a researcher at INESCTEC, which is a Portuguese Institute of Transfer of Technology associated to the University of Porto and to a few other universities mainly in the northern region of Portugal. So I'm here to get us all talking a bit about regional cooperation, about building SDIs which are distributed and that aim at aiding regions to support several types of governance. So basically, this the workshop is divided in two parts. First, the first part is about what brings us here and what are the opportunities and the motives that drives us. Then a bit of what is the common ground that unites these two case studies. I say two case studies, but they are actually, of course, two different projects that run at their own pace and with their own outcomes. But it's interesting to stop a bit and look at them and see what is common, what are the common challenges, what are the ways that have been used to overcome them. And then a second part in which we will focus on its open discussion. So we will focus on discussing what have been the barriers to implementation, what are lessons learned, what did we actually achieve, and I think that will be actually perceived in my colleagues' presentations, and then future steps, and that's it. So what are the drivers? Why do we build this kind of infrastructures? To understand the present, well, to know what we have inherited in the past, to know the current status. So what is the status in my administration and in my territory and in my neighbors, because they will also affect me, and the other way around. In order to define common policies, so we need to understand what is happening so that then we can project the future. And then to assess how these policies are being implemented on a first step. And that may, of course, lead us to real-time monitoring, and that is yet another challenge. And more important than that, what is the impact of society so that we can close the cycle? Then challenges, of course, everybody has their own systems and their own providers, and we need to get a consolidated view. So this is step number one, and it's always a challenge, no matter what kind of spatial data infrastructure we are aiming at build. Then how do we, given that this is the fact, how do we deliver integrated tools to citizens and to the economy that is located in my region and in the others? How to incorporate real-time monitoring again, then to deliver high-quality integrated forecasts. And there is also some debate that we can make, because there are already world global forecasts. So what is the room for local forecasts in the middle of that? And then to figure out, of course, how will my plans affect my neighbors and vice versa. So we have the adequate legal framework. We have the Inspire Directive. It has been transcribed to nearly every country legislation. And in further annexes of the Inspire Directive, annexes 6, 7, for example, there is the clear need not only for invocable services, but for harmonized services, which means it's not enough that I can just make a request to that partner's system and get something out of that. I need to make a request to that partner's system and to that other one, and to build something out of that. And maybe a picture is not enough. So we have our politicians have compromised us to build these frameworks, and they established as targets 2020. So how are you going to do it? Then we have the adequate technical framework. There is hundreds, well, dozens, if not hundreds of specifications. Most of them I have known since at least, well, before 2000, 1998, 1999. Some coming from the OGC, then adapted by Inspire. And they have become more and more mature. Then we have compliant implementation, so we have everything. How can it go wrong? And yet, sometimes it goes wrong. Or at least we need to, well, to put some effort so that it does not go wrong and it does not stall. So how to avoid it and overcome it, it's also something that we can debate here. What have we done so far, and how can we still improve it? So as for the reference architecture, I believe this is known to everyone working in these domains. So I took this picture from the OGC, and we have pretty much everything here. So we have the access services, so-called portrayal services and data services to access data, to access maps, to access points of interest, to access any kind of geometry. Then we have processing services. I'd say that we barely have touched these ones, but I will show you a next slide on what we have mostly done and we have mostly not done. So here you have pretty much mature technologies implementing WMS, WFS, WCS, tiling services, and then sensors. So there is a very wide variety of sensors, and of course, sensor fabricants are not so keen on knowing these standards, and maybe it's not their duty to do so. But it is in our best interest that we connect to these services as transparently as possible. Then, of course, discovery services. So this is pretty much where we are focusing our effort now. Then discovery services. Discovery services are also very resource intensive, let's say at least that. Because after you have your interoperable services running and you can query them and search them, then how does it go when you try to do the same in the services of your neighbor, even if they are using the same technology? And we had that experience, for example, in Raia, one of the projects that we will talk. Well, the first attempt, it went awfully wrong. And we would like to debate that as well. Then a bunch of encodings, GML, NetCDF, SLD, KML, well, anything you can imagine, which is fed into clients, either web clients, either mobile clients, or generic clients like Google and the overlay services and Google Earth, for example. So where do we stand? Pretty much both projects have address this, the ones that I'm going to talk about. They implemented WMS and WFS coverages as well, tiling services as well. Then sensors with the sensor observation service. There is a lot of more standards here that we still did not cover. We have used pretty much the two most mature implementations that we found, the Pi source, which is from OS Thetis, and the 52 North as well. Then, of course, deal with all these encodings, observations and measurements coming directly out of SOS and sensor ML as well. Then NetCDF, which falls here, well, in some way. So here we have some underlying technologies that deliver us WMS and WFS. And you have something else that the scientific communities associated to Earth and ocean monitoring use, which is threads, which somehow maps to some parts of this figure, but it's not still as smooth as it should be. So threads implements, of course, WMS interface so that you can see your forecasts and as a series of images. And you have part of threads which goes up here to the catalog because it allows you to search for them and to search for what's inside of these NetCDFs according to their properties, to their variables, but they are not CSW compliant. And some effort has been put on having this to index threads, but it goes only not as deep as it could go, for example. It doesn't go into the data, and that's where it starts to get interesting because, quite honestly, nobody likes to fill in metadata. So either it is something a bit autonomous and the metadata emerge at least partly from the data, or it is a very boring process. Not only boring, but time-consuming. So we need to articulate things so that they are built in a way that the effort for our users to maintain these platforms is tolerable. Otherwise, it will become unsustainable. Then, of course, client applications. These are actually some snapshots of our clients, both web and mobile, which here are just tiny pictures, but we will show them bigger in the next slides. And of course, this data for the services came, well, at least in one of the projects, mainly from stations like buoys or wind towers or anything like similar. So for the first case study, which is spatial data infrastructures for the Porto metropolitan area, my colleague Lino will talk about this. So we have defined a physical and logical architecture for this SDI, in compliance with the standards, of course, and based on free software. And I mean this as the regional platform, because in each place there will be their own software and their own provider, and no one is going to mess with that. And this is for the Porto metropolitan area, which is a nut-free region in the north of Portugal, comprised of 17 municipalities with these 1,900 square kilometers and nearly 2 million inhabitants. And I will pass the word to my colleague now.
Já ver onde é que se aponta nisto. Vou ver. Okay, good afternoon to you all. As Artur introduced me, I will talk about an implementation of a regional SDI, and I'm going to present also the case study that was the implementation in the metropolitan area of Porto. My name is Lino Oliveira. I'm a researcher on the same center that Artur is in ESCTEC. Regarding the topics that I'm going to talk to you about, of course, first of all, I'm going to make some context and the rationale that move us to this work. Talk you about our proposal for architecture, and then we'll dive directly in the case of the AMP and talk about some issues. So, what was the problem that we face? Currently, municipal and regional SDI do not allow sharing data in real time with each other in a transparent and independent and easy way to perform. As we know, all the information must be managed and maintained by those who produce it. And the geographical information should be easy to integrate with other sources. And of course, the aim that we point that different SDIs in different hierarchical levels should, in fact, communicate with each other. And that was the problem, because the experience tells us that that's nothing, an issue that doesn't occur. So our motivation was to aim developing a physical and logical architecture for a regional SDI, of course in compliance with the INSPIRE, and one other topic was based on free software. And with this we aim to provide real-time information, updated, dynamic between different levels of implementation. And in here we are addressing the municipal level and the regional level, that is the one that the metropolitan area fits. So our architecture proposal divides in two layers. One is the municipal layer, where it will be introduced the information, considered all information provided by each municipality. And in the second layer we have the regional SDI. In this level, this SDI can provide its own information, but also can be fed by the municipal SDIs. So this is our architectural proposal. Of course, we are not talking specifically here today about the national or super-regional level, but the idea is to build like we are building a brick of wall. So we have to give them the same aspect. So regarding the metropolitan area case study, Artur already talked about this topic. I'm going to move on and introduce what was the goals that we aim to reach with this implementation. And the first goal, well, we considered it that a goal and at the same time a challenge. And why? Because our goal is to empower the municipalities that constitute the AMP to have interoperable information following the INSPIRE directive. The reality is that we have the municipalities, they have GIS infrastructure, but I'm not going to say all the municipalities, of course, because there are different levels, but the great majority doesn't have the information, don't provide information in a standard and interoperable way. So the first goal for us is to make this first step, that is the first step, but is we can think that is a small step, but like someone said, it's a small step for man and a leap for mankind. But in here is the small step, but it's an important and a step that it's in some ways some difficult to overcome with the reality. Another goal, of course, was to implement the regional metropolitan SDI that allows optimizing management and provision of innovative service to citizens with data from the municipalities of the MP, but obtained with interoperability standard mechanisms. And one other issue important is that without changing the normal functionality of each municipality. Because, as Artur earlier said, we have lots of proprietary systems, old, new, so we didn't want to change, to apply a change to the things. And of course, compliance with INSPIRE. Well, I talked about the goals, now about the challenges. If you can imagine, work with 17 municipalities, there are 17 different ways, 17 different realities, and well, not all municipalities are in the same level, as you can imagine. So someone, proprietary municipal GIS, closed, didn't have too much room to evolve, and in some cases we are still facing early stages when it comes to GIS. So we have to manage these two things. But we have goals, we have challenges. This project also showed us some opportunities, and one was to increase efficiency in communication between the different hierarchy levels, the municipal, the metropolitan, and aiming the national level. Foster the implementation of sectorial GIS applications sensitive to the territory, and with this create, in fact, innovative service to citizens. And also, this project presents also an opportunity to promote this experience and this infrastructure to be used with another regions or communities. Also, one opportunity that was in fact really interesting was the fact of the AMP also inherits competence to become the Metropolitan Transport Authority. So, applying to all the information that they exchange with the municipalities, they have this competence as well. So, in that case, we have the Metropolitan SDI this is a project that not is terminated yet, but it will be in a couple of months. And we already have the Metropolitan SDI, we have the municipalities, 17, that are now working with standards, with interoperability, and we aim to integrate the information also in the same, using the same architecture with the transport operators, the metropolitan area, 37, and we intend also to give the next step to make an interoperability with the national level, that is with this CGEST, that's a platform for collecting information regarding the transport operators and transport options in all country. Now a little more technical. I want to give you a quick look regarding the architectural and the overview, the physical architecture. So we have, of course, data, spatial data. In a spatial database, we have also information gathered in the network attached storage. We have document and process management. I'm not going to talk about LDAP, it's a little detail. And we divide it in two components, intranet component and an internet component. In the intranet, we have also the applications that are used inside, connected with all the infrastructure. And then we have the internet component that integrate, of course, the applications services, as well as the catalog for we easily get the information through the metadata, and the capacity of provide information in a standard and interoperable way. Now, very quickly, I'm going to show you some snapshots of some of our apps, just for curious. We have done here, for instance, that this information gathered here is, in fact, obtained in real time from the municipality. So, if one municipality updates their data, the information in the metropolitan level automatically is updated as well. And you can see here another example. So, thank you. I want to present also the colleague that's working with me in this project, Paulo Monteiro, and we are here present also Evelyn Oliveira, that is belongs to executive board of AMP, and will give some personal testimony of how this implementation is actually impacting with the AMP in the second part. So I'll pass the command to Artur. Thank you.
Only briefly to introduce the other project, the other case study. Well, if this first project is a case of regional cooperation inside, well, a regional administration, the second one is cross-border cooperation. So it involves not only in the same country, but across borders. And of course, challenges are a bit the same. The domain of application is different. It is more, this is a marine SDI. So there is a lot of data here coming for the ocean, for quality of water, for forecasts, and of course also the sensors. This is a collection of projects that run, well, they are still running, but they've been started in 2009, 2011, 2013. The last one is still closing. And you have here the collection of partners also working on this SDI. So I'll just pass the word to Bego, which will be talking about this project in detail.
Good afternoon. My name is Begoña Vila. I work for the Institute of Technology to control the marine environment in Galicia, northwest of Spain. And I would like to talk to you about this history, this project, this observatory. I think it was the perfect school for us. We have learned a lot because about 10 years ago, several regional and national institutions in Spain that were working with weather and ocean forecasting observations realized that a network for controlling the coast of Galicia was necessary. So, besides this, because the Portuguese coast is just, I don't know if you are familiar with the political division in Spain, but we are in the northwest and Portugal is just in the south of Galicia. So the data coming from the Portuguese coast was essential for us. And talking, VR, we decided to create a project or call for submission for a project called Raya, the Raya project, in 2008. Just remember the year, 2008. So when in 2009 this project was approved, and the objectives we have in mind were the following: that's improving the observation of the ocean, improving the weather and oceanic forecasting models. We wanted also to establish a platform, as Arthur said before, just to share data between the Portuguese and the Galician partners, and develop new technologies to build and to improve the observatory and to produce end users tools. 2009. So we wanted to establish a platform of cross-frontier interoperability for the management and distribution of the data. In 2009, we started to listen about INSPIRE, the words INSPIRE directive, these protocols that began with WMS, WFS, we were all new in that field, but what we knew was that we have this kind of information. We have information of the HF radar from Galicia and Vigo. These data are like rasters with arrows, with a time component. We have also a time series coming from CTDs and tide gauges, and real-time information coming from the buoys we have along the coast. And we have also this kind of information models that are rasters with a time component, 3D information also. So it was a mess. It was a lot of information we want to share, we want to distribute, but how to do that? How? Well, the aims we have This information I've been talking about, most of them is belongs to the Earth and Ocean Science community. Most of the information we had also were from the GIS community. These communities are, I think they are not still, yes, in common, no? They have a lot of differences, they have a lot of things we have to put in common because it's not easy to share this information. But we can, I don't know if you have experience in this kind of information, the oceanic weather and so on, but it's quite a question, no? Just to, quite a point to match with it. And we have another problem, that's all the data we had, was distributed in different nodes. There were partners in Galicia, were partners in Portugal, and we didn't want to focus, to centralize all the information in just one node. Political reasons was true. Who was in charge of distributing all this information? The people from Portugal wanted to keep their information. The people from Galicia wanted to keep our information. So we decided to create a federated, distributed, and distributed architecture. Inspire was there, so we thought that follow the directive was a good idea just to share this information. But because there were a lot of problems. We have, remember, 2009. That was the picture we had in 2009. We have a lot of sensors, buoys, CTV, so on. The infrastructure, the data source were like that. We have a lot of databases distributed in a lot of institutions. And we began to work the protocols Lino and Arthur have mentioned before. But this information without a client is nonsense. So we had to figure out how to solve this problem. Inspire gave us a solution. We knew we had to help the users to discover, to view, to download this information, and taking account that we have also installed, some of us, a GeoServer, threads, and even a SOS server. We try to put all together, make something useful, no, for the community. The problems, the challenges. We wanted to use a catalog, and following this protocol, OGC, we decided to use GeoNetwork, but it was nonsense to have a lot of catalogs. No? We wanted to have just one official catalog for all the Raya Observatory. So we have decided that the NESC installed, no, or developed the official catalog, harvesting the rest of the metadata from the other catalogs we have already installed. The other problem we had was the metadata. As Arthur said, metadata are boring, it's very difficult. It's not very difficult, it's a boring task, but it's essential. And besides, we have realized that we didn't know from the information we needed to complete the metadata. For example, we had data from, I don't know, environmental facilities, but we didn't know who who or where or when or why these facilities were developed or installed. So we realized we have lost a lot of information needed to create a good metadata. When this, or if the metadata was already created, it was not compliant with Inspire. So we had to rewrite all the metadata. That, I think, it was a very difficult task, and it's not complete yet, and we are still working on that. If we talk about the view services, we decided to use this WMS that in 2009 was what is that? Nobody knew what that protocol was, and but nowadays I think everybody is familiar with this protocol. But 7 years ago it was just like I don't know, a future movie or something like that. The problem we had is that we were using overall NetCDF data. This data is a scientist format, and it was not prepared to be served as WMS. We found a plugin called NCWMS, which help us to serve this information through Threads. Threads is a server. It's a kind of server for this kind of information. I don't know if you are familiar with that, but this for our communities is essential, and this is also a headache, because I think Inspire has forgotten Threads, or Threads has forgotten Inspire, and they are not compliant. Threads is not Inspire compliant, and we're trying to talk with the people of Threads and Inspire us to help us to integrate this format. And to download this information, Threads again. How can we download this information, this Threads information, if Inspire is not prepared for that? So they have developed this plugin I told you, the NCWMS. I think it has the WFS also, but they are not. One thing is the protocol, and another thing is if these protocols are Inspire compliant. They are not. They are not compliant. We are also serving data through SOS. SOS is nowadays Inspire compliant, and they are working on that. But till now we have to install a lot of versions, we have make a lot of tests, not always successful. Arthur has a lot of experience with this protocol. If you have any questions, I think Arthur could help you with that. But at the end, finally, as you know, these protocols, these services had to fulfill some quality tests. We have run these tests in our servers, and they have passed the test. So this is a good thing we have in our system. And just for finishing, we have created some clients to view all this information. It's information from Portugal and Galicia. This, for example, is a source request, but we can also view GIS information. This information I told you, this near real-time information from voice or from models. I think we are quite proud of the result of this of this client. We have also a catalog that is harvesting information from the catalogs of the rest of the observatory, and this is an example of an end user product. This is the Percebeiro. It's like a Winguru, but for Percebes is like barnacles. You know, that's helping. It's a tool we have developed to help the people who are fishing or collecting barnacles to know. They can know if the conditions of the sea are propitious for going to the sea and working. So this is has been developed with the help of information from all the observatory models and GIS and so on. And this I think this is a good example of that. We have more examples, but yes, I don't want to bore you more. And this is all. Well, I don't know if you have something to add.
Continue. Thank you. So we have seen. Sorry. So we have seen some projects that actually yielded some results, and that were, well, they were a process in which we all learned quite a lot, and that allow us to take us some lessons. So first of all, we are using quite a few of heavy and in some cases complicated protocols and standards, and people want simple things to use. So generic is in opposition to what is user-friendly usually. So there is some balance to achieve here. There are challenges from the technical perspective, of course, but I'd say that these are the easiest ones. So this one we can tackle. Of course, when you put it in the regional level, then you have that problem times how many regions are participating, because then you have to try to, well, I was going to say push, and we do have to push something in there, but not to replace what people already have, because we cannot have the luxury of pressing the reset button and just saying, hey, look, this is a new platform, now go and start using it. So we need to adapt to what exists, and in some cases it's challenging. But so maybe the risk there is pace. So usually the pace from that is required to adapt a solution to an interoperable solution is not compatible with short-term agendas and expectations. And you do need to deal with that. How can you not, usually regional and local administrations have their own agendas, and they are for, let's say, 4 years, pretty much everywhere. And how can you not take that into account and show results fast? But fast results usually, in some cases, if you are not aware, and if the providers are not aware of these standards, result in some, well, engineering hack that will return a pretty map, and that is satisfying, but what that's not all I need to have in order to move forward. So there is some balance there. Another thing is the involvement of stakeholders. So you want this platform to do exactly what? To manage the whole Porto region? Manage what? You see, each kind of information, each layer of information, which for me are pretty much, okay, it's a GIS, it's a map, needs not to be taken under that assumption. It needs to be dealt with properly. Even if you only handle one layer, it needed to do it properly and with a purpose. So that is something that we also learned. And if we go back a few slides, let me just try to reach there. I just put there in the encodings, the provocations, which is CSV. So there is all those encodings, and if you look at them, some are pretty complicated, also semantically rich. But in the end, people will ask, can I have that in my Excel? And so it goes through text formats and to something that people can easily understand and use outside of these platforms. So, and then something else that I'm just launching a few questions. Of course, for example, the catalogs that Bego mentioned, and it was actually a problem because we had WMS everywhere and metadata in the WMS, but then we plugged in a GeoNetwork on top, and what we got from that was not so good. So it was actually very difficult to find and look what you're looking for. So you need to explain people how to use Inspire code lists, Inspire control vocabularies, and how to make the best use of them. How to configure the WMS, because you deploy a geo server or whatever server, and we are talking about the simplest stack. And it will put maps on the web, and I'm happy. And then what next? Because when I want to give the next step, it's not ready. And, well, it's interoperable. I'm using Inspire standards. It goes even worse when you go to the sensors data, because then it's a nightmare. And for example, NetCDF. NetCDF is something that we cannot ignore, of course. I have had several projects in which NetCDF keeps popping up. And they are going to still use NetCDF for long-term years, and there are, of course, this approach between the two user communities. But the thing is, if you want to encode data in a binary format, which has some heading with some information, but which already uses some common vocabulary because it uses CF, then we are going to use NetCDF because everybody else will be using it. Here in Europe, in the US, you cannot go around it. So you better just, if it's not fully incorporated in Inspire standards, then pull it in. Pull it in and try to integrate it as best as possible because you cannot go around it, for example. And then in a global scale changes everything, not only in GIS, but in terms of information systems, but also in terms of the role of the organizations. So what is my role as an organization in a globalized way? Well, it was already mentioned here, Wind Guru, for example. Why do I need to acquire more wind data and to give, isn't it not enough the forecasts that they do? So how, of course not, but this is something that needs to be understood because for the common user out there, well, it already exists, it's done, and it's done on few resources. So I'm not sure if you want to add some of this then to this discussion, some of your own experiences. It's pretty much open discussion. If not, I would ask Felino to at least say some words here about your experience in IMP.
Well, first of all, hi to everybody. It's nice to be here in Barcelona. In Expire conference, for me it's a bit hard because I'm an architect. I'm sorry. Most of your language I don't understand. I was always trying to understand some of the signs of the figures, but I think for me it's quite important in the aim of Porto and the metropolitan area of Porto. We are very committed to this project because when I arrived to this active board of metropolitan area of Porto, I was invaded with companies and people talking to me about smart cities. And everybody's enchanted about smart cities. And we can do this and we can do that. We can do a lot of projects and development and transform this in some tools of planning, and this becomes very useful for people. This is in the first week. In the second week, I was trying to know how many schools do I have in my 17 municipalities. We didn't know. How many health centers? How many lines of transport? Things like that, you know. Because to plan, you need simple things. But everybody was telling me, well, each municipality has a GIE system. So they have their own information. And we also have some things that are inside metropolitan area that municipalities need to know. So this smart metropolitan area was based on emails. Oh, send me by email, 17 emails saying how many schools, and then one email saying what we have, and this was very hard. So one of the most important smart strategic project was to combine the GIS, because I don't think that, well, basically, after that we discovered that the municipalities have their GIS system, geographical system, but they don't have really an SDI, as you call it, a spatial database, a combined database. Most of them, they didn't have it. And also, so we asked sub-regional level, there was a regional level and a national level. And we discovered also that people were developing other projects. And the national level, they were sending us like spreadsheets of Excel to fulfill some database so they can build their own GIS. And the regional entities were also want to combine the 17 municipalities to send some spreadsheets of Excel every week or every month so they can fulfill some data so they can have their own GIS. So, simple question. Why is everybody doing the same? Why can we cannot combine that? So that's where I discovered Inspire, and then I find these people and ask them to come and help me, and we started this project. I think we need to get metropolitan area more smart, but before thinking of very up to date and upfront projects, let's start from the beginning and let's build the foundations of the thing. It's like, let's make an SDI structure so everybody can interchange information. And this is basically my personal testimony, what I was asked, is that unfortunately we have to start from the basis. And start from the basis was building an infrastructure that now can transform metropolitan area in a much more smarter thing. And then we can, maybe next year, maybe the beginning of next year, we can make smart city and the smart city spread all over the 17 municipalities. Well, I'm not repeating the difficulties that we found because 17 different people, 17 different ways of things, 17 different software, 17 different departments, 17 different politicians, and also 18 because our system was also different and has to combine and comply with the national system. Well, this was very impulsionated by the transport system because, as you know, if you go here in Barcelona or in Porto, or in the metro or in the bus system, you look at the sign and see 3 minutes for the bus to come. And the people responsible for that are the authorities of transport, for instance, as an example. And that database, that real-time database, has to be settled in some place. And in our case, the correct place to put that database is in metropolitan area of Porto. But we didn't have the infrastructure. We still don't have it completely. We have a part for the metro. We have a part for some of the public bus company, but we don't have it for everybody and for all the 17 municipalities. I think after this project, we are able to have it. So, the fact that we develop one common GIS was something that was very attractive through all municipalities. First of all, in political terms, and I think I have to explain you that, we use some strategies. And the first strategy is to convince them that there were different levels in each municipality, so the money will be to develop their own GIS. And so, well, we try to get some funds and we're going to develop your GIS so everybody stay in the same level, or at least very close. But in fact, the project changed our goal and combined it more to a plan where we want a special database which is centered in metropolitan area. Because of course it's impossible to develop every GIS system in municipalities to be with the same kind of software or properties, but it's very easy as well. It's easy to make them work together. And then if we make the 17 work together, then we can we make our relations with the national system. That is the next step that I hope that our team can do it next year, and I think is quite important. And also, this will be the base of the construction of the most important planning instruments that we are developing in the next few years. Even European, Community European Funds projects, but also in people's lives, because if we are very in need of the development of a more strategic development, territorial development, we need to know all the information. And in fact, geographical information is the base of everything. And so I think the fact that we have a combined spatial database that is assembled in our natural structures and entities like the municipalities, if they update their GIS, the spatial database is also updated at the same time. So there is no failures and there is no repetition or redundancies, like putting public people doing the same thing over and over again. And in this case, I think, which it's quite important for us, for the metropolitan area, because none of you said that, in Portugal, I think is the only system in terms of public entities, like municipalities and metropolitan areas and regional level, that is based in an interoperative system. I think we are the only example that are almost finished that works interoperating different GIS and makes a real, very real spatial database infrastructure, which makes us very proud, and I think is probably what justifies my presence here. So thank you very much.
So basically, I would say open questions. If anyone wants to have some.
I'm very impressed by the amount of results you got and the amount of work you put into this.
I think it was the next phone.
well, the
Don't touch any button anymore.
I'd like to thank you for all the comprehensive presentation about the case studies. Case study.
Yeah. This was.
Do you want me to shout a little bit more?
No, I can hear you. It's just a bit, maybe a bit confusing.
It's actually my curiosity. Is the
Yes.
third presentation that like nowadays. To which extent there was a good statement there. Your aim is just to bridge the gap between the GIS and the EOS
Yes.
commitments by adhering the inspired specs. That's my curiosity. To which, at the end of the day, to which accuracy, or actually, to which extent did you manage this goal by adhering the inspired specs for that specific case study?
Do you want to answer? Well, I think it has been a process that actually has brought both communities together. I'd say the Earth and Ocean Observation community is, first of all, is a very active community. And there have been some initiatives with the open oceans that has helped bridging this gap. So the thing is, under the hood, they use different technologies, and there are actually differences. And like I said, NetCDF is a reality that Inspire cannot obviously ignore. And for now, what was done was to mask it up and to make it show us a sequence of images, for example. But we start to going deeper. And the fact is, NetCDF is not so bad, for example. I don't want to reduce this to a NetCDF discussion, but it's a very good example. Because it's already using a controlled vocabulary, so that can feed up immediately into Inspire vocabularies, if they want to use it. There are clear rules how to derive new variables, for example. And the thing is, when you have done that, you have earned the ability of pulling metadata while people are still populating data. And people will care for data and care a little less for metadata because, well, they just want to use a file that they can use in their systems, in MATLAB, in R, in whatever software they use. So the thing is, you can, for clients, you can still use Inspire, you can still use the Inspire standards, but you need to go deeper. And I know that the OGC and NASA have been connecting to basically merge these two worlds, and they have been making some consensus. So that's pretty much how it's going. And we are using what is being done and also in other projects. For example, I have a project which I did not bring here about marine diversity. So about seamounts. And I have pushed a bit of OGC into that, a bit of Inspire into that, using the sensor observation service. The problem is that at some point you start from up here, from the top, whereas you need to look at the data from here because that's what scientists will want to look at. So maybe a bit too late, but the discussion is getting there. And the guys that are responsible for the sensor observation services, for example, are keeping par with the difficulties, and it's coming closer, but it will take time. So you cannot reinvent how sensors work, and you cannot reinvent how to organize data. But then again, in 90% of the cases, and I've seen this from the C application domain, but also from wind application domain. It's columns with headers, and if these headers have some common names or some standardized names, then you have most of your problem solved. Then, of course, you need to add some other layers of metadata, which, for example, in XCDF, they come in the top of the file, in the header of the file, and some others that are at the service level. So at the service level, you can also say, well, this data is produced by this and that and that. And then you have a stack of things. So you have the service level metadata. You have the file level metadata that fills in the gaps. And that mostly is derived from the data, which has been my struggle, because you see, everyone tries to solve their own problem. So if from Brussels someone asks, well, give me a catalog of data, then the institution to which they ask will say, here is a metadata editor, please fill in your metadata, which is, of course, the way of isolating the problem, and it will work to some extent. But that's it. The trick is to some extent, because the effort is too big. Asking people to fill in metadata and keeping filling metadata is a very, very boring thing to do, at least. Well, but it's not sustainable. So the thing is, we need to take the best of each community, and I'd say that both have a lot to learn from each other. But there are very nice things here, and if we want to evolve towards, well, smart cities or smart oceans or smart whatever you want, you do need to have semantically rich representations of what's in there. And you need to have protocols in which you not only read from in a common way, but give orders in a common way, which will be next step.
I don't know if you are familiar with the technical guide of these themes. The 15, I think, is the ocean features, 16 is sea regions. I'm working here in Spain in the technical group. We have realized that these technical guides were written by people coming from the GIS community, and they have forgotten this kind of information. So when they have written all the specifications, they come from another community, and they didn't know that this kind of information, the NetCDF, this community exists. Now, from Spain, we are trying to talk with these experts or whatever, because we think is fundamental that this information would be included somehow, because if not, we are not going to be able to report this information, this kind of information, the ocean models, weather forecasting. Yeah. So for us, it's very important to know that there are other countries that they have the same problem as here in Spain, and this is a fight we have to fight all together, because I think we have time till 2020 just to change this technical guide and to include this kind of information. If not, we are not going to be able to. What's the solution? We have okay, our information is not going to be inspired, never. So we are not going to be able to inform Europe about this kind of space data. So if a crisis, like an accident, a pollution accident happens, we are not going to share, or we are not going to be able to share this information with the rest of countries because it's not INSPIRE compliant. But it's not our fault. Somebody has forgotten that this information exists. I don't know if your experience from other countries, but So,
The thing is, and this is why I left this here on the bottom. The thing is, sometimes, and I think this is, when you think from the top to bottom, you tend to look at the nodes as, well, they are just providing information, which is what feeds everything else. So the thing is, it can reach to a point in which the policy is established, strangle the nodes down here, because they only have to provide information. But the thing is, it can be a very heavy task. If they don't have the right tools, if they don't have the knowledge on how to interoperate and interoperate well without a very big effort, you can strangle them here, and then I think the rest will fall. So if you hear how to persevere in the global context, if, in my point of view, if an institution exists, then it has some purpose in the world. So it exists to control the water quality in Galicia, for example. I'm talking about Intecmar, not just to provide information to the upper levels. And this is where the plus, the advantage of their work must be, of course, brought to the other levels and to bring value-added services. So I do think, as we are providing also aid to the metropolitan area to bring the GIS from the municipalities to the regional level, you cannot reach a point where you forget the lower level, because that's where the information will keep being updated. And people will do their work, because it's their mission in the world. So, before I was saying a provocation about Wind Guru, why do you need anything else? Because you do need high-level resolution for local things, for example, for near-the-coast predictions. For near-coast predictions, which are not so good with global models. And the thing is, well, we now have, or are going to have, Copernicus also filling in this gap and giving us new products. But the thing is, where does the information come from? And how to maintain them? Because if you leave them outside the loop, then it will fall from the base. This is my bit me.
Okay, thanks, Hans.
Thank you. Anything else? Well, if not, I think we have closed in time, 10 minutes before. Oh. Well, thank you very much.